10 years ago, in 2014, I created a concept aircraft which became the avatar for my Instagram page, MPV Aviation Illustrations. Renee and I have decided to review this concept aircraft and develop our Boxwing 2.0. Transferring my original sketch ideas into 3D, I used a software program called T-Splines, which I believe is no longer available. I understand Autodesk 360 purchased the rights to T-Splines and are now using that in their Autodesk 360 package. Before T-Splines became Autodesk, I managed to purchase the software and use it to model the freeform shapes of my concept aircraft and develop this 3D model, which I was able to import into SolidWorks. Both Renee and I have now reviewed the aircraft model and planned on ways in how we could make this a 3D printable and flyable experimental model aircraft for aerojtp.com. One of our first considerations was propulsion and the type of EDFs or propellers that we would use for this particular design. And we've opted for a 6-bladed prop, which I've modeled up in SolidWorks very roughly, just trying to get enough detail and geometry on the prop so that we can use it in our visualization and development of the aircraft. Having discussed the issues of a single prop design, both Renee and I have decided to make it a twin prop model. In this instance, we removed the central nacelle, engine nacelle, and implemented 2 smaller props either side of the body in line with the vertical stabilizers. This configuration gives us great control of the airflow over the control surfaces, both in the vertical stabilizers as well as the flaps and ailerons. One main consideration was launching and how to launch this particular model, so we opted for a vertical start. Here you can see we have developed outriggers on the extensions of the wings and also reinforced the top wing structure so that this small little plane can be launched standing upright on its tail. As we developed the model further, some of the trickier components such as the wing sections and flaps and transitions between leading edges and upper wing surfaces needed to be resolved using zebra lines there in SolidWorks to identify curvature and continuity. Once the wing geometry was complete, the ailerons and outer control surfaces on the upper wing as well as the vertical stabilizers were developed. One of the challenges was how we were to control both the inner and outer angled ailerons on the wing. And so Renee and I developed a combined single servo operated twin control surface linkage, whereby we used ball heads and pan heads with 2 separate linkages to the 1 servo arm to control the inner and outer ailerons on the upper wing. The next challenge in our project was to develop a linkage between the 2 rudders. Our initial concept involved a servo mounted on the tail of the aircraft with a common link bar between the 2 rudder surfaces. We were looking for simplicity and ease of assembly the limitations of the stroke of those rudders, however, made us redesign that particular concept. And in this instance, we opted for a centrally mounted servo further within the fuselage, with two linkage arms extending out from the servo to the rudder surfaces. Once the rudders were dialed in, we looked at a way of also tidying up the linkage openings through the fuselage. The key to this was making sure, firstly, that the slots in the fuselage were large enough for the actuation rods to pass through, and then establish a shroud that went over those exit points to tidy up the arrangement on the fuselage with those linkages. Once the 3D development of the ailerons and rudders had been resolved, Renee and I have worked on the cover to the battery compartment and the internal servo access area. Opted for a large single formed cover. In this instance, we've split it. Also worked on the vertical stabilizers and access for cable management, so having a cap that allows cables to easily be fed in through the vertical stabilizers. And final tidying up of the outer wing servo linkage, just to give that a bit of an aerodynamic bulge, which would clean up the model. So be sure to follow along as we develop our Boxwing 2.0 and get it to our first maiden flight, and then hopefully the STL files available on aerojtp.com. Renee and I look forward to showing you the results.